Hello YouTube, my name is Johnny Vanderwood with Repo Technologies, and today I'll be going over named EIGRP configuration. This video is a part of a series of videos that will cover Repo Technologies Confluence webpage on IT how-to videos. So following Repo Technologies Confluence page, we will first baseline our routers. Then we'll configure EIGRP using name mode, and then we'll do some verification. This video will also have a little bonus configuration. Today I will also show you how to quickly set up Ansible and configure named EIGRP using a playbook. So without further ado, let's get started. As we can see from my GNS3 network diagram, I have two 7200 series Cisco routers, each with loopback addresses and a connection in the middle. This R1 also has a connection to my NAT cloud over here. This will come in later once we set up Ansible on our local machine. My GNS3 application is running on my local server, and my operating system is Ubuntu 20.04 Focal FOSS. So before we start configuring these routers for named EIGRP, let's git clone my company's baseline repo from Gitlab. First, let's log into Gitlab. We'll head to our project, and we'll hit clone with HTTPS. Next, we'll open up Visual Studio Code. And now we'll git clone using that URL. If you're following my other videos, there is a deeper explanation into what I'm doing here. But for now, I'm going to go a little quick with cloning this repo. Just putting in some credentials here. Oops, my bad. And now that we have cloned this repo, let's open it up in a new window. And here we can see that cloned repo in our Windows Explorer pane right here. Now let's get our baseline and copy and paste it into R1 and R2. Here we have R1's baseline and R2's baseline. Let's go back into GNS3. Turn on our routers, and then console in. R1 and R2. Awesome. Now while these two routers start up, let's copy these baselines and make sure that they're correct. This looks good for R2. Let's paste this in here. Now let's do R1. Let's paste this in here. Now that we have a good baseline, let's configure named EIGRP. First, we get into global configuration mode, which we're already in. Then we type in router EIGRP, and then instead of doing an autonomous system number like we would do in classic EIGRP, we're going to put a name. Then we define an address family. And also the autonomous system number. We still need that for EIGRP. Now, one of the main configuration differences in named and classic EIGRP is the modular approach it takes in configuration. All EIGRP configuration is actually done under this subconfiguration right here, router.af. This is different from its previous configuration, classic mode, where you had to jump around the CLI to actually configure your EIGRP and all of its options. Awesome. That is named configuration mode right there. Another way it differs is in its actual metric calculation. Let me bring that up for you before we get any further. Classic EIGRP mode, when calculating its metric, used 256 as a constant in its formula. Well, named EIGRP uses something called wide metrics. This is created to handle the faster and larger throughput and bandwidth of cables beyond 1 gigabit. So we can actually get an accurate metric. And it will use 65,536 as the constant in its new formula. Named mode uses wide metrics. Classic mode uses the classic metrics. Now, even though these formulas are different with the consonant, they are still compatible. Let's get back into this configuration. Address family, EIGRP4, unicast, autonomous system 5. Now let's do our network commands, which don't change from classic mode. Awesome. That's all it takes to configure EIGRP. Now that we've configured EIGRP, let's do some basic verification. We will type in show IP EIGRP neighbors. Let me tab it out so I make sure I'm spelling it right. And boom, we have neighborship. Now let's check our routing table. Okay, so this is what happens when you mistype. Let's go ahead and do this over on router 2. This is why that tab completion is so important. And as we can see, router 2, we have EIGRP routes in there. So this is all it takes for named EIGRP. So now, let's get into some bonus rounds, some fun. Now we're going to configure this local repo that we just cloned for Ansible. And we're going to make an Ansible playbook to do named EIGRP configuration. All right. So let's get to it. First things first, let's go to VS Code. As we can see here, we do not have any Ansible configuration in our current repo. Just to make sure. Yep, this is our only folder. So let's do some Ansible configuration. Let's go ahead and make a directory, and we'll just call it Ansible. Or actually, let's call it automation. Let's get into that directory. And we need a couple files here for Ansible to work. The first one is our host file, and I'll actually come back into VS Code to make that. Host. And in here, we're going to put our host. Then we'll put this variable, Ansible host, with its IP address. This IP address I'm typing in here is actually the connection to the NAT cloud that R1 has in GNS3. And then this won't make sense right now, but it will. Just keep following along. These are also just connection variables for Ansible. Okay, so that's our host file. It's that easy. We're just defining the host that we want to manage from Ansible. Next, we're going to do our Ansible.cfg file. And for this, I'm going to go back to Gitlab. I'm actually going to log in to my personal GitLab, and just pull an Ansible configuration from one of my past projects. Boom. Now we have these two files. Both of these are needed to make sure Ansible is working correctly. Now let's make some connection variables. We do this by creating a folder called group vars. And then we'll make a YAML file called all.yaml. And this YAML file will be the connection variables for Cisco iOS. And again, I'm just going to go back into my old GitLab and just steal a file from here. This is the great thing about having multiple projects. You can always come back and steal some code that you previously created, and it makes your life a lot easier. So these are pretty self-explanatory. When Ansible makes a connection to go into a network device, it uses SSH. And we need a couple things of SSH. We need a username and a password. We also got to tell Ansible that it's going to be going into a Cisco iOS, that the CLI is going to be a network device. And then these three commands here are if that router is set up to have a password on from user mode to privilege mode. So that's all this is. And now anytime we run an Ansible playbook, we will use these connection variables. So that's all there is to that. Now, before we can make a playbook, we have to configure NAT on router 1. So why do we need to do this? Because our local host is using 192.168.122.1 to connect to our GNS3 emulated network here. Well, this direct connection should be fine, but the host behind R1 needs to be able to talk to this NAT cloud, which is our local machine, and this local machine from the outside network needs to be able to SSH to both these routers. So we need to set up NAT on this R1. And then we also need to set a static NAT statement so that the outside network can SSH to router R2. So let's do that. First, let's get the lay of the land. Okay. So first thing I'm going to do is just create our loopbacks. And we have this loopback here just to have more network statements to create in our playbook. So we can actually advertise to R2. And now let's set up that direct connection to that NAT cloud. Subscription to internet. Give it an IP address. If you know about the virtual network adapter in Linux, then you know that 192.168.122 is always the subnet with a /24. And this is even true for your virtual machine network in Ubuntu. We're going to enable CDP, because why not? And then we're going to tell this to be our NAT outside address. Give it a second while it creates that NVI0 interface, which is needed for it to be able to do its NAT translation. Then let's no shut. Before we move on, let's just do a quick test. And we can't reach that. Now let's create a static route so we can tell R1 where to go to reach the internet. Awesome. Now let's tell it the NAT inside address, so the inside network that is going to be translated. And that'll be fast Ethernet 00 right here. Let's just expand this a little bit. Next, we're going to define which addresses are to be translated. So we're going to do that with a standard access list. And we're going to permit the 172 network. Wildcard mask. We're also going to permit some loopback networks. We'll just keep this simple. We'll just do one loopback on R1 and one loopback on R2. Perfect. Now, let's do our NAT statements. Just checking something here, excuse me. So now we're going to do IPNAT inside source list standard access list 1. And then we're going to choose the interface on which is going to be doing the translation. Then the keyword overload to actually do port address translation. Awesome. Now let's stop right there and let's do some tests first to make sure our inside network can reach the outside network. And the first thing I got to do here is make sure that I'm advertising the correct networks. Okay. R2 needs to know about this network over here to actually be able to reach the outside. So let's do some tests and make sure it can hit my local machine. Awesome. Now let's go to R2 and do the same. And we'll source this fastest than at 00. And this is all we need, this ping right here, to know that we can hit from inside to outside. But again, the whole point of this is so that our local machine, the outside network, can reach an SSH into R2, the inside network. Well, with NAT, inside to outside is possible, but outside to inside, you need to enable technology called port forwarding. And we do that on Cisco using a static NAT translation. So let me show you what that is. So again, we're going to start by doing a NAT configuration. And excuse me, let me just bring up my other window I had. Not that one. So IPNAT inside source static, right? So we're going to make a static entry. TCP, because SSH uses TCP, to the inside address that the outside network doesn't know about on R2, using port 22, and the outside network to be able to SSH to this IP address is going to use port 23 and R1's outside IP address. So that static NAT entry is what allows us, the local machine on the outside network, to be able to SSH to the inside network. So let's make sure we have everything configured correctly. We have a good IP address. We can still ping. Let's make sure that we're actually doing NAT translation. So show IP NAT translation. We have that static one right here. And we can actually see R2 getting natted to our local machine. Great. And again, if any of this is foreign to you or confusing, feel free to check out Trepa Technologies' Confluence page on IT How-Tos, where I actually typed up how-tos that deep dives into this technology. All right. Now let's create our playbook. So we're going to create a YAML file. We'll call this named EIGRP.yml. First thing we're going to do is put the 3 dashes to signify that it is a YAML file. Then we're going to put a comment here. Playbook to configure named EIGRP on R1 and R2. First thing we're going to do is define a host. Our first host is going to be R1. Next, we're going to actually put a task. Then we're going to give it a name. Configure. And this name can be whatever you want. Named EIGRP R1. And then we're going to put the iOS config module. This module right here in Ansible actually lets us tell the router that we need to get into global configuration mode. And these lines are going to be our actual statements. So in R1 will advertise 10.2.2.0. 5. And we'll put another one in there in case we make another loop back. And then we need the parent line, which is actually just the sub-configuration that we need. The sub-configuration modes. Get rid of that. This will be address dash family IPv4 unicast autonomous system 5. What we're going to do here is just copy, paste, and just change this to R2 and to actually put its networks we want to advertise. Great. And now let's bring up R1. We'll bring that back in just a second. And let's go to our terminal and actually run this playbook. EIGRP.yml. And as this runs, we're actually going to get a syslog message telling us that we got a configuration change. We got that on R2 as well. So let's see if we have more EIGRP routes. And we do. So that was a little bonus round network automation for you guys. So as you can see, it's pretty simple to do simple network automation, right? If you need more information on Ansible or anything relating to this video, please feel free to go to our Confluence page down below or check out Ansible's documentation page. It's actually very thorough and very handy. So from everyone here at Treppa Technologies, thank you. And remember to keep learning every day.